Welcome to the project demonstration of IoT based smart energy meter system with automatic billing and fault alerting with controlling from the Blynk application. So here we are going to send the energy meter readings along with billing details to the Blynk application with help of ESP8266 Wi-Fi module. And next, if the readings are exceeds the threshold value by saying manually, we can control the device continue directly from this Blynk application only from anywhere in the world just by selecting this on off switch. And the next feature is we can get the alerts notification whenever this alert switch is pressed. So here we are using this switch as a fault identification pin to the microcontroller. So whenever this presses, we will get the alert notification into the application, and this can be monitored and controlling from anywhere in the world just by logging to the Blynk app by the given credentials. So here the flow is we are going to provide the 230 volts input to this energy meter parallelly to this regulated power supply board. It has the three stages. One is rectification, filtration and regulation. After that we will get the 5 volts regular power supply directly to the PIC microcontroller. From this motherboard we are going to distribute in the 5 volts power supply to this PC817 optocoupler and electromagnetic relay and 16x2 LCD and ESP8266 module. So here PC817 purpose is which is the interfacing connector between the energy meter and the PIC microcontroller. As the main purpose of this one is, so we are going to calculate the consumed energy by this load based on this LED blinkings on this energy meter. So when it blinks at a duration of 3600, then it is considered as a 1 kilowatt hour. So one blink is equal to 1 by 3600 kilowatt hour readings. So that is a calculation. That blinking rate will be given to the microcontroller through this PC817 optocoupler. So we can provide direct LED output as we are getting DC only. But if is there any short circuit occurred in this board, then that microcontroller may get damaged, which is the main controlling motherboard. So in order to protect this controller, we place the optocoupler, that is optically coupled, so connector between the LED and our microcontroller. If anything goes wrong, then only this IC will damage and simply we can replace that. And the next is electromagnetic relay to control this load, and LCD display to display the status continuously on the LCD, and a Wi-Fi module just to pass the information and get the information from this Blynk application. So interfacing connections are A4 pin to this optocoupler and relay at B0, C6, C7 for this ESP8266 module, and LCD to BT to B7. And the main controller number is PIC16F73, and this fault switch interface at the C3 pin. So let us see demonstration. Before switching on this kit, we need to enable the hotspot in your phone. So go to hotspot settings and change the hotspot name to PROJECT4993 without any space, without any capital letter, and password 129. After enabling the hotspots, log into the Blynk application, enable the data also, data hotspot. Then only you can switch on the power supply to the kit. So there is a welcome message on the screen initially. So we need to hold this microcontroller till the system connected to the Wi-Fi. So once it connected, so there we can see the one device is connected in your phone, hotspot settings, and after that restart this microcontroller. Right, now it is going to be the 00 readings. So starting onwards, so we must and should reset the switch after establishing of connection. So now we can control the devices just owning the device. So let's wait for some time so that the reading will be calculated. As we said, for every blink 1 by 3600, it's going to be the 0.006 kilowatt hour, and the bill also calculated 2.44 rupees per blink, sorry, per kilowatt hour. So we'll get the same reading here. So if you want to control that, you can controlling that. So if they didn't respond to your Blynk application inputs, then you can just restart the microcontroller, and there is a fault switch. When the fault is occurred, so there we get the app notification alert something, there is a fault. So we can see that, and you can isolate the power supply to the load. Right.